My name is Christian Rose. I'm a double major in mechanical engineering and physics at Southern Illinois University, Carbondale. And I'd like to talk about MeasureIt, which is a data acquisition software written at the University of Washington to conduct and monitor physics-based experiments. Modern physics experiments involve multiple measurement channels which monitor or control a wide range of parameters, which can include temperature or voltage, for example. So say an experimentalist wants to test the resistance of a transistor or some other device. They would need equipment to supply a voltage and measure the resulting current. The user then needs a means of controlling the instrument to set the desired parameters. The acquired data from the sample must also be communicated to the user in a practical format for analysis. The current industry standard for data acquisition is a commercial software known as LabVIEW. LabVIEW supports a visual programming language known as G. Here's an example of a simple LabVIEW code where two numbers are being added, the sum is reported, and there's a 1-second delay before the process is repeated. The numbers to be added are defined behind the scenes, meaning that sometimes crucial information is not displayed in the main diagram. Along with hidden information, adding some complexity to this system can result in a very convoluted diagram. These qualities lead to code which is very difficult for outside observers to interpret, causing a large difficulty in sharing experimental setups. QCoDES is designed as an open source and user-friendly framework for instrument control and data acquisition, which allows its users to virtually control their equipment through drivers contributed by the community. It's been gaining popularity in recent years as a modern alternative to commercial software such as LabVIEW. It's written in Python, so programs can easily be shared between research groups. Users of QCoDES establish virtual stations to represent an experiment, then define the necessary instruments, which are assigned parameters based on the functionality of the equipment. These parameter values can be set as a constant, swept through a range, or measured as another parameter is manipulated. Although QCoDES is more accessible than a software like LabVIEW, it still requires a fair amount of programming knowledge. Users must learn to use QCoDES syntax to create a station with the necessary equipment defined, assign the desired parameters, create a loop to sweep through values and obtain data, format a database to organize the log data, and generate plots for data analysis using a separate Python library. To simplify this process, the software called MeasureIt has been created at the University of Washington. In this short amount of code, MeasureIt allows users to define an independent parameter to be swept through a desired range at a specific rate, along with followed parameters that are tracked and measured as the independent variable is manipulated. This software includes advanced features such as live plotting, an organized data saver, and sequential scanning. In addition to the functionalities achieved by command line tools, MeasureIt provides an intuitive graphical user interface which can expedite the experimental design process for users with no programming experience. The GUI automatically creates a QCoDES station and provides almost all of the same features as previously shown. Here, we can add an instrument, which automatically populates the associated parameters. Users can also easily identify which of these parameters are to be swept, which are to be measured or followed, and which are to be held constant. The parameters are then populated into the main window, where the sweep attributes can be easily defined in the central widget. The far right window illustrates the sweep queue, which lists multiple sweeps that are to be performed consecutively. The key missing feature of the GUI currently is the ability to perform 2D sweeps, where the outer parameter pauses at each step interval for the inner parameter to be completely swept to the desired range. Along with live plotting for the entire sweeping process, Sweep2D also generates a heat map, which plots the followed parameter against both independent variables using color to represent the third dimension. Currently, the GUI is being modified to support the 2D sweep previously mentioned. The first beta version of the software is also set to be distributed by the end of August. This version will include all of the functionality presented here, along with many optional arguments that were not shown. A new module is also being written to provide a method of plotting previously exported data using PyQt graphs with zoom functionality, functions to fit data both linearly and non-linearly, and the option to customize the appearance of the plots. I'd like to thank the undergraduate research program of the University of Washington, specifically the MEMC-REU. I would also like to thank Dr. Zhu and his research group, especially Josh Kai, for their guidance on this project. Thank you.